Hey there, class. It's that moment you've all been waiting for, our Chapter 8 final review. This review is a little bit different because it is based on student requests. So I've compiled all of your feedback into 4 big ideas that you were most curious about practicing some more. So we're going to work through those 4 big ideas right here in this video. And if you have trouble or more questions afterwards, please come see me for some follow-up in the Math Center. But without further ado, we're going to get started and jump right in. Remember, you can always pause or rewind the video if you missed something or want to hear it again. Now, first big idea, identifying polynomials, degrees, and leading coefficients. Now, before we get started, I'm just going to add leading coefficient to my list so I don't forget to include every single piece. Now, that's often a mistake on tests, is when they ask us for multiple things: the polynomial, the degree, the leading coefficient. That's when we forget something. Now, standard form. Remember, that's going to be in order based on the exponent from largest to smallest. So when we're doing it, the one thing to remember is that the sign stays with that base and exponent. So for this polynomial, our standard form would be negative 6x to the 7th plus 2x to the 6th plus 4x squared minus 9. Now, is this a polynomial or not? Well, to be a polynomial, I can't have a negative exponents. I can't have a variable denominator, and I don't have either of those in this polynomial. So it meets all the criteria. This is a polynomial. Now, what is the degree? Our largest exponent. Now that it's in standard form, it's nice and clear. Our largest exponent is 7, so our degree is 7. And the last question asks us about the leading coefficient. Now, the leading coefficient is just the coefficient, all right? So that means we look at the line leader of our standard form. It needs to be based on standard form. All right, once you're in standard form, then your leading coefficient is just literally your line leader. So for this polynomial, the coefficient, the term leading my polynomial is negative 6. Notice the x is a variable. It is not part of the leading coefficient. The leading coefficient is just the coefficient. All right, so next up, our next big idea is combining like terms. So let's jump into a couple examples. The first one, we're being asked to add 2 polynomials together, but right now they are a little cumbersome. We got some parentheses in there. So when we see that we are adding these together, before we can combine them, we've got to get rid of the parentheses. So step number 1 is to distribute, and watching out for negatives. So this is negative 35w squared plus 15w. Then I'm going to distribute. Don't forget the w on the second term. That's a very common mistake because both are being multiplied by 5w. Then I'm going to distribute the next terms. So 2w times negative w squared, that's going to be negative 4w cubed. 2w times 19w is positive 38w squared. And 2w times positive 2 is positive 4w. Now, I've distributed. The last thing to do is combine like terms. So I want to match up my w's with my w squareds, my w with my w to the first, and w cubed is the only one of its kind, so it stays by itself. Now, once I do this, I always want to put my answers in standard form. We should be defaulting to that always from now on, now that we know it. So I'm going to combine these like terms. The first one is w cubed. That's the largest exponent. So we'll start with negative 4w cubed. Then negative 35w squared plus 38w squared. That's going to be positive 3w squared. And then 15 plus 4 is 19w. Now, the reason why I didn't have to use inverse operations is because there was no equal sign that I was trying to move across. And the reason why I added the exponents here but didn't change them here is because up here we were distributing, and that multiplication adjusted or affected our exponents. But once we're just combining like terms, we're just putting like things together. We're just playing a matching game. We're not changing any variables. All right? Next up, we are now subtracting. Now, subtraction you want to be careful of because it's easy to forget that you are subtracting. And in this case, it's a little cumbersome because it's not just a basic x and y variable. So I want to make sure that I match up exactly the same terms, and to do that we're going to use our strategy we've practiced in class, which is colors. So first I see I have 2u squared x. The exponent is above the u, so the only other term like that, exactly like that, would be negative 4u squared x. Next up I see negative 3ux and negative 6ux. And finally, positive 4ux squared minus 4ux squared. So now that I've matched up my like terms, I can combine them a little easier with avoiding more mistakes. So first up, I have 2u squared x minus 4, or minus negative 4 u squared x. So remember, we have this negative sign in the middle. We're subtracting a negative. So 2 minus negative 4 is really 2 plus 4. So that's 6u squared x. Next up, I'm going to do negative 3ux minus 6ux. And that's going to be negative 9ux. And lastly, 4ux squared minus negative 2ux squared. So minus and negative is plus. So that's going to be plus 6ux squared. All right. So that would be my final answer because I don't have any more like terms. And when it's multiple variables, it's difficult to do an accurate standard form. So you can just leave it like this. Let's keep going. The next one, we're combining like terms, but this time we have a binomial and a trinomial. So we do our double distribution in this situation. This is what it will look like when you need to use double distribution. All right. And I know I'm multiplying and distributing instead of like adding or subtracting like we did up here because there's no sign in between the parentheses. So this will be 2y times 4y squared plus 6y minus 7 minus 3 times 4y squared plus 6y minus 7. So I've split up 2y and negative 3. One goes here, and the other went here. Now I'm going to double distribute. I'm going to distribute each of those to the same trinomial. All right? Now, when I distribute, I'm multiplying, so I do need to adjust my exponents for this distribution step. So 2y times 4y squared, 8y cubed. 2y times 6y is positive 12y squared. 2y times negative 7 is negative 14y. My next side, negative 3. Keep the negative with the coefficient or with the constant, I should say. Negative 3 times 4y squared is negative 12y squared. Negative 3 times 6y is negative 18y. And negative 3 times negative 7 is positive 21. Now I want to identify my like terms. So here's y cubed. And I don't have any more y cubes. Next step, y squared, negative y squared, y, and just 21. All right, my constant stays by itself. So standard form and combining like terms, I'm going to do both steps at the same time. So standard form first will be 8y cubed. Next, my exponent 2, that's 12y squared minus 12y squared. Oops. So those are going to just cancel out, both of them. Next up, I have negative 14y minus 18y. That's going to be negative 32y because it's a negative minus, or a negative with another negative. And then lastly, positive 21. And that would be my final answer. All right, let's move on to the next one. So we have this time an equal sign. So this means we're going to have to actually solve for u equals. All right, that's what our answer is going to look like because they're not just asking us to simplify. So we're going to distribute. So that will be u squared minus 5u plus 8u equals u squared plus 2u minus 4. Now we have some like terms we can combine here. So it's u squared plus 3u equals u squared plus 2u minus 4. Now, I want to combine like terms at this step. There's no more on the same side, but remember, we are solving an equation and we know the rule is no matter what you're using the rule for, if we are trying to move something across the equal sign, we've got to use inverse operations. So now that I can't combine anything further on the same sides, I'm going to combine across the equal sign. So let's move negative u squared over to the other side by subtracting. And that actually cancels out both of them. Then I get 3u equals 2u minus 4. That's just a minus sign. Then I want to subtract 2u to get the 4 alone and the u's all together. And that leaves me with u equals negative 4. Now that my variable is alone and I used my inverse operations to get there, I'm done. All right. So let's move on to our next big idea, one of the more recent ones, factoring. So we've been asked a lot about different methods for factoring, but what's confusing some of us is just when to use which method. So let's break it down. When we want to use GCF, the best way to know when to use GCF is if it's 2 or 3 terms. So here's a 2-term, here's a 3-term trinomial. And if you have more than one letter, more than one variable, all right? If we have only one variable, we can use one of our other strategies. So when you see 2 variables, that's when you know to use your GCF. So this would break down to, let's see, 2 times 2 times 3 times 3. So that's 4 times 9 is 36. Then times x times y times y. Now the other term, negative 48x squared y. So we're going to start with negative 1 times 2 times 2 times 2, that's 8, times 2 again, times 3, that's 6. So 8 times 6, 6 and 8 equals 48. Then times x times x times y. Now that we've expanded those into factors, we want to find common factors. So to be common, they have to appear on each list. So there's a 2, here's another 2, then a 3, another 3. Oh, I highlighted too soon. There's only one 3 on this list, so I want to definitely make sure to not use that by accident. Then there's an x and one y. All right, so those terms that are on both lists, except for this 3 that was an accident, we're going to pull those outside of the polynomial. So that's going to be 2 times 2 is 4. 4 times 3 is 12. And then 12 times x is 12x. And 12x times y is 12xy. So that is what we pulled out. What's left over? 3y for the first term. So we pull that out, 3y. And then on this other side, what's left over is negative 1 times 2 times 2. So that's negative 4 times x. So minus 4x. Now, just do a quick, mental check. 12 times 3 is 36. That matches up. A negative 48. 12 times negative 4 is negative 48. So this is our answer. It works. Now, because this next one also has multiple variables, we're going to use GCF. 7 times u times u times t times t. 7 times 3 times u times t. And the last one is negative 1 times u times t. Now, when I look for my like terms, my common factors, I see 7 is not on each list, 3 is not on each list, but u is, and t is. So that's what we can pull out of the expression, ut. And then what's left over? 7ut plus 21t minus 1. That's our answer. Now, these next terms, or these next polynomials, have 4 terms. I want you to notice that. If they're asking you to factor and it looks like this, well, we can factor 4 terms by grouping. So when you see 4 terms like this, we can split those up into 2 groups. So that's how we're going to approach polynomials with 4 terms like this. And then for each of those groups, we're going to factor it using the GCF. So this first one would be 2 times 2 times b minus 1 times 2 times 2 times 3 times b. So that's our first term. Okay, broken down. This is the middle. Now the other term, we're actually going to skip this one because we're doing one just like it. And so I have more space. So this is 4b squared, 4b squared. 2b minus 6, negative 2b minus 6. Sorry, this is, so negative 12b. I should have said that. Now, because we've split this first term up, that's what these are, we can break that part down into factors. So if I look for common factors, just like I was doing before, I have 2 times and 2, another 2 and 2, and one of the b's they have in common. So this can break down and be pulled out. So we end up with 4b on the outside, and then b on the left, and on the right, negative 1 times 3 is minus 3. Now, oops, I should not have, okay, we are going to do that one from scratch because at this point, we've gotten a little flustered. So if that happens and you find yourself on a test, like we just did where we were kind of like, oh, I made a mistake. Well, let's start over. We have 4b squared minus 12b plus 2b minus 6. Now, the big takeaway from this example here is that I'm not going to try and just pick back up where I left off, because that's what I did here, even though like I didn't split it the way I normally would. And I think that's what threw us off down here. So what we can learn from that and what we can avoid doing ourselves on our own test is making that same mistake and not just starting fresh, all right? A fresh start can change a lot of problems. I'm going to group. Now, this time I was trying to squeeze it into too small of an area. That also threw me off. So this time I'm going to break this one down further over here. 2 times 2 times b times b. And then this one is negative 1 times 2 times 2 times 3 times b. This one, this second term, we're going to break down. 2b becomes 2 times b. Negative 6 is negative 1 times 2 times 3. So, like terms, for this first group, we have 2, 2, 2, 2, and b. So when I pull out those common factors, I have 4b, and then what's left over is b and negative 3. Now, on the other side, I have 2b, and then this is where I made my mistake last time. I didn't leave enough space to really spread these terms out. This 2b and negative 6 are separate terms. So when I look for what's in common on both of those, when I'm looking at their factors, 2. So I'm going to pull out the 2. That's their common factor. And then the factors left over on the left for 2b, what's left over is just b. And for negative 6, what's left over is negative 1 times 3, negative 3. Now, when you're using this grouping method, you should end up with a step that looks like this. And at this step, these terms inside the parentheses should be the same. If they are, then you've done the right thing. And our last step is just to put them together, 4b plus 2. So you combine your outside terms, and then your second binomial is just b minus 3, the matching term. All right. So now let's move on to some more factoring. But this is the last type we learned of. We've done the grouping, we've done the GCF. Now this is where we're going to use our table. We called this the A times C method. Okay, so remember we do A times C. 1 times negative 32 is negative 32. So we want factors of negative 32. And we want to find the sum of 4. Now, the reason I knew to use a table is because in this polynomial, I have a quadratic. My largest exponent is 2. It's all the same variable, and there are 3 terms. It's a trinomial. That's when I can use this table, when it looks like this. My first coefficient, my leading coefficient is 1. So this is ax squared. A is the leading coefficient plus bx plus c. All right, that's our quadratic form. When it's in that form, we use our table. So we're looking for factors that equal negative 32, but also give a sum of 4. So let's see if I want to equal negative 42, well, or negative 32, I should say. I know negative 8 times 4 would be negative 32, but when I add those together, I would get a sum of negative 4. So because I want a sum of positive 4, I'm going to flip this around. I'm going to make the 8 positive, the 4 negative, so I still get a product of negative 32, but now my sum is positive 4. Once I do that, my answer is b plus 8 and b minus 4. It does not matter the order that your binomials are in. All right? Let's try another one. This time, n is our variable. So we want to find factors of negative 28 that have a sum of negative 3. Now, if I'm thinking of factors of negative 28, if it's going to be a negative product, I need to have one negative, one positive factor. But the negative should be larger because when I add them together, I want my answer to be negative. So let's think about 28. We can do 4 times 7. Now, one of those needs to be negative to make it equal negative 28, and I want my sum to be negative, so the larger number should be negative. And then when I add them together, I get negative 3. So my answer would be n plus 4 times n minus 7. All right, next examples. So the last big idea that we have is going to be solving equations and specifically quadratics. Now, for each of these, to solve these quadratics, we're going to set them all equal to 0. All right, so some of these already are. When they are, if it looks like this, so here we have x times x minus 32 equals 0. We have a binomial here. Trinomial? So we are going to split this up. X equals 0 and x minus 32 equals 0. Because since this is multiplication and it equals 0, and I know it's multiplication because we have x times x minus 32. So I can split those up, those factors. Here's one factor, here's the other. And I know because it equals 0, one of them has to equal 0. Now I can't be sure which one, so I'm going to just keep x equals 0. And on this one, I'm going to get x alone, and x equals 32. So those are both my answer. I need to include both of them to get credit on my test. Now here we actually have two binomials. So we have binomial times binomial. So when this happens, we're going to split them up. 2y plus 5 equals 0 and y minus 4 equals 0. Then let's get 0 alone. So subtract 5. 2y equals negative 5 divided by 2. So y equals negative 5 halves. And on this side, y equals 4. So that would be my answer. Now, for this one, we first of all, don't have a polynomial set equal to 0. So that's step number 1. So to do that, I'm going to add 26 to both sides. So I get 8x squared plus 26 equals 0. Now from here, I want to factor. All right, so I need to factor. I can't just solve for x because this is x squared. And this is 26x, just x. So because they're not like terms, I can't subtract. That's why I have to factor first. So 26 and 8, let's see. 26 divided by 2 is 13. So this would be 2 times 4 times x, and this would be plus 2 times 13 times x equals 0. Now, what they have in common is 2 and x. So that comes outside. And then inside the parentheses is going to be 4x plus 13 equals 0. Now notice by factoring, I no longer have an exponent, of 2. So I can combine these like terms and solve for just x. I no longer have x squared. Now I have monomial times binomial, so this is going to become 2x equals 0 and 4x plus 13 equals 0. Divide by 2, x equals 0, and subtract 13 and divide by 4. Oops, sorry guys, I was in the zone. All right, so subtract 13 and divide by 4. X equals negative 13 over 4. Sometimes you'll get a weird fraction, and that's okay. That's fine. All right. Now, the last one over here that we have is a table one because I have to set it equal to 0. Right now it's not. So I'm going to subtract 18a from both sides to get it on the same side as all the other terms. And that gives me, now as I subtract it, I'm also going to put it in standard form. So I know that these aren't like terms. I can't subtract negative 18a from either of these terms. So I'm just going to write them all down below in order. So a squared minus 18a plus 80 equals 0. Now we want a table. We want a product of 80, but a sum of negative 18. Now, if I want a product of 80 and a sum of negative 18, let's see, 80 divided by 10 is 8. And if I do negative 8 times negative 10, I get a positive 80. But if I add them together, I get negative 18. So, and let me just differentiate here. So now since these are my factors for this trinomial here, or quadratic I should say, we want to set it equal a minus 8 times a minus 10 is equal to 0. Now, a minus 8 equals 0, a minus 10 equals 0. Get a alone. A equals 8 and a equals 10. So that's our final answer. Both need to be included. Now, there's one more thing I want to go over with y'all, and it is a bonus question. Now, on this bonus question that you will see, it's not going to be exactly the same numbers, but it'll be the same concept, where I give you a quadratic and ask you to solve it. Now, we know to solve it, we want to get it all set equal to 0. But now, The difference is we actually have a number in front of the x. Up until now, we haven't. So because it's the a times c method, when we do our factor table, we want factors of a times c. So for this problem, a times c would be negative 21. Those are the factors we want to find. And we still want a sum of b, so that's negative 20. Now, if I want to find factors of negative 21, that would be negative 21 times 1. And if I add those together, I get negative 20. So I still find my factors the same way. And to solve it, I still set that, it was x, yep, x minus 21 and x plus 1. I still set that equal to 0. So we get x equals 21 and x equals negative 1. All right, and that would be my final answer. So folks, you have some big topics to review based on this video, but if you have any questions about any of it, please come visit me, and I will see you for your test. Good luck studying. Bye.